In this video, we'll look at how to perform group comparisons using non-parametric inferential statistical tests. We have here a hypothetical data set of, say 30 participants and who have been assigned either to a control or treatment condition. And let's say these are junior high singers in a choral program. We have a pretest measure of the frequency with which they make music at home. You can see there's never, ranging from never, almost sometimes, almost every day, and every day. So these are 5-point scales. And then we have a post-test measure of how often they make music at home. We have an indicator as to whether they're on the honor roll at their school. We also have an indicator as to whether they intend or not to join choir in the beginning of their school year in September, and then at the end of their school year in May. This is whether they intend to join the high school choir after the junior high. So we can use this hypothetical data set to illustrate how to perform these group comparisons for, as you can see, we have ordinal variables and we have nominal variables, right? Several of them here. So let's ask a basic question. Perhaps this is an experiment where we're trying to increase the likelihood that students will sing at home or make music at home. So we could look at the effect of whether the students were in the control or treatment group on the degree to which they make music at home following the experiment, their post-home music score here. So to make that comparison, this is a two-group, an independent group comparison. We have some kids in the control group and some kids in the treatment group, and one ordinal dependent variable, right? This is not an interval scale variable or nominal, it's ordinal. So we would go to Analyze, to Non-Parametric Tests. We're dealing with independent samples, kids in the control or the treatment group. And then SPSS gives us a somewhat counterintuitive menu option here, but we can click the Fields option and put in experimental grouping as our group variable, and the post-test degree to which they make music at home in the test field. And then under Settings, we would choose to customize tests and choose the appropriate test. So since this is a test of independent groups with ordinal data, we would use the Mann-Whitney U test. And then we click Run. Computer churns for a moment and we get a really simple output, and this says, yes, you should reject the null hypothesis. And it even tells us what that null hypothesis is, that the distribution of the post-test degree to which the kids would make music at home is the same. So we can say, yeah, we can reject that. In other words, the distribution is different. And if you double click this window in non-parametric tests, you get more information. So you can see that the Mann-Whitney U test here depends on mean rankings rather than, say, mean scores. And the mean ranking of the treatment group is higher than the mean ranking of the control group. This is the test statistic that you would report, the Mann-Whitney U. And again, you have your two-sided p-value here. So what we would end up saying is that the kids who are in the treatment group are more likely to say they make music at home following the experiment than the kids in the control group, or in other words, that the experiment worked. So we can follow a similar set of steps to do a two-group comparison for dependent samples. So for example, maybe we're interested in whether, regardless of whether the kids were in a control or treatment group, their likelihood of making music at home changed significantly prior to after the experiment. And so we have one group of 30 students being compared at one point in time, and the same group of 30 students being compared at another point in time on the same measure. So we can again go to the non-parametric test routine and analyze. And this time we're dealing with what SPSS describes as related samples, same thing as dependent or paired samples. And again, we set our fields. And in this case, we want our two repeated measurements here, two dependent samplings. And then again to Settings. We'll customize tests, and for this type of test with ordinal data and dependent samples, we'll choose the Wilcoxon test. And click Run. And again, we get a simple output that says we should reject the null hypothesis, that the median of differences between pre-test degree to which they'll make music and post-test degree to which they'll make music at home is 0. So we can interpret that to say that there is a difference between their likelihood of making music at home at pre- and post-test. And again, if we double-click, we get more information, and we can see that there's positive differences. So in other words, when you think of post relative to pre. At post-test, the participants as a whole, regardless of control or treatment, are more likely to be making music at home. And again, we have our test statistic here and our two-sided p-value here reported. So in other words, there's a significant difference from pre to post-test, suggesting that the students at the end of the study are more likely to make music at home. So let's look at a comparison now with ordinal data, or sorry, with nominal data. So we can compare, like maybe we're interested, for example, in seeing whether the representation of honor roll students is the same for control and treatment group participants. So we can do that by using a chi-square test of independence. And in contrast to the others so far, we can find that test in the descriptive statistics crosstab menu. So we'll put experimental group as our row and honor roll status as our column to make our 2x2 chart here. And click the statistics window. And we'll say, yeah, we want a chi-square. We could also ask for phi and Kramer's V, since that can serve as a form of effect size. And we could also ask for standardized residuals, so that we can get a sense of if there is any disproportionality, in which particular cells that disproportionality can be found. And so SPSS tells us, yeah, you have 30 people, there's no missing data. It gives us the cross-tabulation, where we have, for example, 10 people in the honor roll that are not on the honor roll in the control group, 5 people that are on the honor roll in the control group, etc. We have our standardized residuals here. And for these values, we're looking for things that are greater than 2 to be indicative of some meaningful disproportionality, and these clearly are not larger than 2. Then we have our test of independence. So our Pearson chi-square value of 3.33 with 1 degree of freedom yields a p-value, significance value of 0.068. And since this is not below the critical threshold of 0.05, the traditional threshold of 0.05, we would say that there is no difference in proportion of honor roll students between control and treatment groups. We again can use, in this case, it's a 2x2 table, so we could use phi as a measure of effect size to get a sense of the magnitude of the dependence here between these two variables. But again, this is non-significant, so this would be a small magnitude anyway. You can interpret this similarly to a correlation coefficient to some extent. So that's what you would do for a test of independence for chi-square. But you can also have questions regarding whether nominal variables change over time in some sense. So for example, we have this variable here that asks the kids, do you intend to join high school choir or not in September, and then again in May. And so we're interested, do their decisions change over time, right? Maybe by the end of the year after participating in junior high choir, they're now interested in participating in high school choir. So we can perform a test to make that comparison from over time and create a statistical estimate of that comparison. So again, we can go to non-parametric tests. And since these are the same 30 kids answering these questions, we'll say related samples. I'm going to reset here and put in our 2 related samples nominal variables. And under settings, again, ask the customized tests. And this time the test you would use is the McNemar's test. Binary data. This is a two options for each. I do or I don't intend binary. Click run. And again, we get a simple output that says, that just gives us a p-value for a particular null hypothesis. The distribution of different values across intention to join high school choir as of September and intention to join high school choir as of May are equally likely. We would not reject that null hypothesis because, again, the p-value is not less than 0.05. Again, if we double click, we get more information. You can see what's really driving this test here, whether people change their mind, right? So did students who initially intended to join now decide to join? Students who didn't initially intend to join or did initially intend to join now decide not to join, right? So again, though, we have our test statistic and we have our p-value for reporting. But overall, we have a non-significant finding here. So we would say there's no change in their decision as a group to join high school choir or not from September or May. And that's using SPSS to compare groups with non-parametric tests. So tests particularly that are suited for ordinal and nominal level data. Thank you very much.